Good morning, student. So today this is our second lecture on semiconductors. In the previous lecture we had seen that the electrical conductivity or the electrical properties of semiconductors, they are different than that of metals or an insulator only because of what? Their unique conduction mechanism. So to know what is that unique conduction mechanism that semiconductor will have, we must have to study the band theory of solids. You know very well that let us consider the simple possible example of sodium. So suppose we are having an isolated sodium atom, means a single sodium atom. Remember, isolated sodium atom can never exist. But let us consider that we are having an isolated sodium atom. What is the atomic number of sodium atom? Atomic number of sodium atom is 11. What an isolated sodium atom consists of? It consists of centrally situated massive region called as nucleus, consisting of proton and that of what? Neutron. 11 protons are here, and surrounding to that nucleus, electrons, which are negatively charged particles, they are revolving in a circular orbit, in a different circular orbit. And according to Bohr's model of hydrogen atom, we know that electrons in the different orbit will have different energy level. So here electrons in the different orbit will have what? Different energy level. Electrons in the different orbit will have a different energy level. So here I have shown the energy level distribution of electron in an isolated sodium atom. So as far as sodium atom is concerned, what is the electronic configuration of isolated sodium atom? See here, in all 11 electrons are there. So out of these 11 electron, 2 electrons, they must lie in what? 1s energy level. So 1s2, 2s2, 2p6, and last one is what? 3s1. 2 plus 2 plus 6 plus 1, 4 plus 6, 10 plus 1, 11. So the electronic configuration of sodium atom are 1s2, 2s2, 2p6 and 3s1. 1s2, 2s2, 2p6 and 3s1. It means if I just consider the atomic structure of sodium atom 1s2, then in the second orbit 2s2 and 2p6, in all 8 electrons are there, and in the outermost orbit, that is 3s1, only 1 electron is there. Remember that according to Pauli's exclusion principle, what Pauli's exclusion principle says, that no 2 electron can have the same set of quantum number. No 2 electrons can have the same set of quantum number. Or Pauli's exclusion principle also states that no 2 electron having same spin can occupy the same energy level, or any energy level can accommodate only 2 electrons. Any energy level can accommodate only 2 electrons, 1 electron having spin up states and other electron having spin down state. 1 electron having what? Spin up state and other electron having what? Spin down state. Remember the 3 points that you have to remember. According to Pauli's exclusion principle, no 2 electrons can have the same set of quantum number, or no 2 electron can have the same spin to occupy the same energy level, or any energy level can accommodate only 2 electron, 1 electron having spin up state and other electron having what? Spin down state. So this is about an isolated sodium atom having 11 electron. So 1s, 2s, 2p6, 3s. In all 11 electrons are there. So in 1s energy level, here these are actually the energy levels of electrons in the different orbit. In 1s energy level, two electrons are shown. One is spin up and other is what? Spin down. This will represent spin up and this is what? Spin down. 1s2, two electrons are here. 2s2, here one electron spin up, other electron spin down. 2p6. So see here we are having the three pairs of electron, spin up, spin down, spin up, spin down, spin up and spin down. And the last energy level, that is 3s energy level, it has only one electron and it is spin up electron. It is what? Spin up state electron. So this is how the electrons are distributed as per their energy level. As per their energy level. So in an isolated sodium atom where there are 11 electrons are there and these 11 electrons will occupy the different energy level which is shown as per this diagram. Remember that during the formation of solid, when a solid sodium is to be formed, then large number of atoms they are packed together, they comes very close to each other. And when large number of atoms comes close to each other, then remember the electron in the outermost orbit. See here, electron in the innermost orbit, they are strongly bound with nucleus. Electron in the outermost orbit, they are loosely bound with nucleus. Means, as far as 3s electron in an isolated sodium atom is concerned, this 3s electron will have a strong force of attraction with positively charged nucleus and the potential energy possessed by 3s electron is U equal to minus of K into. If I say capital Q is charge on nucleus, small q is charge on electron, then minus kq divided by R represent the distance of that electron from the center of the nucleus. This is the potential energy possessed by electron in any circular orbit. See here, electron in the innermost orbit, R is small. Means this term is what? Large, but it is negative sign. Means its potential energy is what? Potential energy is highly negative or potential energy is small. As we take the electron from higher and higher orbit, electron in the outermost orbit, its distance from nucleus is large. Means potential energy, when R is large, this entire term is small, means potential energy is what? Small but negative, means it is ultimately potential energy will be more. So greater the value of R, greater is the potential energy possessed by electron. Remember, electron in the outermost orbit or electron in what? The high energy orbit, electron in the outermost orbit or high energy orbit, it is loosely bound with nucleus, and during the formation of solid, when solid sodium is formed, then atoms comes close to each other. See here, two atoms of sodium, if they brought very close to each other, means if I reduce the distance of separation between them on the order of 2 to 3 angstrom unit, means distance between them will be reduced to 2 to 3 into 10 to the power minus 10 meter. What happens? Actually, the orbits of two atoms will overlap. There is an overlapping of atomic orbital. This is atomic orbital of first sodium atom. This is atomic orbital of what? Second sodium atom. So 3s orbit of both the atom, they will overlap. Same thing will happen with all the remaining orbits. Means all the orbits of two atoms, they will overlap. They will what? Overlap. And due to overlapping of atomic orbits, when atomic orbits of two atoms overlap, look at this electron. Electron in 3s orbit or electron in the highly energetic orbit will have a strong interaction. These electrons in what? 3s orbit, that is electrons in what? Highly energetic orbit, they will have a strong interaction with neighboring atom. As far as isolated atom is concerned, the only potential energy of this electron, it is what? It is the Coulombian interaction between electron and that of a positively charged nucleus. But when two atoms comes close to each other, then as far as this electron is concerned, initially there is a force of attraction on this electron by the nucleus of that atom itself. But due to overlapping of orbit, this electron is attracted by the nucleus of neighboring atom also. This electron will be acted upon by what? A repulsive force. Means on this electron in the outermost orbit of both the atom, they are now having a strong interaction with the neighboring atom. Means they get attracted by the nucleus of neighboring atom as well as they get repelled by the electrons in the neighboring atom. It means what happens to the potential energy of electron in the outermost orbit? Initially this electron has this much potential energy. Now when atoms comes close to each other, the potential energy of this electron is equal to, already this electron has potential energy minus kqqq divided by r. If I say this distance is r, then plus of minus kq2 into q divided by r2. This distance is r2. Again this electron will exert a force of repulsion. So this is kq1 q2 divided by r3. So there is an addition of potential energy. It may be added or it may be subtracted. So remember, whenever two atoms comes close to each other, then the potential energy of the electrons in the outermost orbit will changes slightly. Only those electrons which are lying in the outermost orbit, that is electrons in the 3s orbit, they have a strong interaction with their neighboring atom, and due to that strong interaction, remember, their energy will change, but that change in energy is very small as compared to that of their original energy in that 3s orbit. Means if I say that as far as isolated sodium atom is concerned, if the energy of electron in 3s orbit is E, in isolated sodium atom, energy of electron in 3s orbit is E, then in case when two atoms of sodium they brought close to each other, there is an overlapping of atomic orbits. There is an overlapping of what? An atomic orbit. So that atomic orbital is converted into what? Molecular orbital. And the electron in the 3s orbit, their potential, because these electron in 3s orbit, they will have a strong interaction with the nucleus of neighboring atom. They will have a strong interaction with the electrons in the neighboring atom. Means the potential energy of electron in the highly energetic orbit, that is in 3s orbit, will undergo a slight change. Means energy of electron in 3s orbit, now it may change to what? E plus delta E, or it may change to what? E minus delta E. And remember, as far as this delta E, which is a change in energy of electron in the outermost orbit, due to strong interaction between what? Due to strong interaction between neighboring atom, is very small. Is very small. Means energy of electron, energy of 3s electron from the first atom its energy now it becomes E plus delta E, and the energy of electron, 3s electron of second atom, now its energy will becomes what? E minus delta E. Means the electron in 3s orbit, 3s electron, now they will have different energy level. Their energies are different than that of their original energy in the same orbit. The energy possessed by 3s electron of two sodium atom, they are slightly different, slightly more or slightly less than that of their original energy. Means that 3s energy level, now initially we are having a unique 3s energy level. When the two atoms of sodium they brought close to each other in order to form the molecule of sodium, there occurs an overlapping of atomic orbital, and the potential energy or the energy of electron in the outermost orbit has changed due to their strong interaction with what? The neighboring atom. So the energy of one of the electron may becomes slightly more than that of original value, or energy of one of the electron will become slightly less than that of what? Its original value. So that 3s energy level, now it is splitted into two sub level. Now it is splitted into what? Two sub level. Means this happens with each and every atomic orbit. Electrons in 1s orbit, electrons in 2s orbit, electrons in 2p orbit, and electrons in 3s orbit. But regarding physics, we will concentrate only on those electrons which are lying in the outermost orbit. So you remember that according to Pauli's exclusion principle, according to Pauli's exclusion principle, as far as electrons in the outermost orbits are concerned, electrons in the outermost 3s orbits are concerned, now they will have two different energy level. One is E plus delta E and other is what? E minus delta E. E minus delta E. Now instead of two atoms, suppose three atoms they are brought close to each other. So what happens to the energy level of these three electrons? Electrons in the 3s orbit, electrons in the 3s orbit will have strong interaction with their neighboring atom, will have a strong interaction with their neighboring atom, and due to that strong interaction their energies will changes slightly. If I say energy of this 3s orbit is E1, this is E2, and that of what? E3. Then this E1, E2, E3 actually they are slightly different than that of what? Their original value E. It may be E plus delta E, it may be E minus delta E, it may be plus or it may be minus. Means that 3s energy level, now it is split into what? Three different energy level. 3s energy level is split into what? Three different energy level, which is shown here. The original energy level, it may be E. One of the energy level, it may be E minus delta E, or it may be what? E plus delta E. E plus delta E. Means when three atoms of sodium they brought close to each other, then the atoms in their outermost orbit, that is in 3s orbit, they will have a strong interaction with the core of neighboring atom. Means they will have a strong interaction with the nucleus of neighboring atom, and due to that strong interaction their potential energy will changes slightly. May there will be a slight increase or slight decrease in potential energy as compared to that of their original energy, as a result of which you can say the energy level in 3s orbit, it gets split into three different levels. It gets split into what? Three different levels, and each electron will have a unique energy level, and it will not violate Pauli's exclusion principle. Remember, according to Pauli's exclusion principle, see here, all the three electrons in the three sodium atom, they are having what? Spin up states. And according to Pauli's exclusion principle, in a single energy level, you cannot have two electrons with same spin state. So here we are having three electrons which are having what? Three different energy level. which are having 3 different energy level. So remember, you can extend this assumption. Suppose we are having 1 mole of sodium atom. During the formation of 1 mole of sodium atom, we know that how many atoms of sodium they comes close to each other. In 1 mole of sodium, we are having n equal to 6.022 into 10 to the power 23 number of sodium atoms. When such a large number of sodium atoms they brought close to each other such that interatomic spacing is of the order of 2 to 3 angstrom unit. So, every atom has 1 electron in its outermost orbit, that is in highly energetic orbit, means every sodium atom will have 1 electron in 3s orbit. In all, n atoms are there. So, how many electrons are present in 3s orbit of what? 1 mole of sodium. So, the number of atoms, number of 3s electron in 1 mole of sodium, they are equal to 6.022 into 10 to the power 23, means roughly it is 6 into 10 to the power what? 23 number of atoms are there. So, how many electrons are there in 3s orbit? In all, there are nearly 6 into 10 to the power 23 number of electrons, 3s electrons are present in the outermost orbit. All these 6 into 10 to the power 23 electron, they will have strong interaction with their neighboring atoms. They had a strong interaction with the nuclei of their neighboring atom, and due to that strong interaction, their potential energy will vary slightly than that of what? Their original energy. Means that 3s energy level, it gets splitted into n number of energy level. How many energy levels are there? Because in all we are having n number of atoms. N is equal to 6 into 10 to the power 23 atoms are there. Each atom has 1 electron in its outermost orbit. So, in all there are 6 into 10 raised to 23 electrons are present in the outermost orbit. Means 6 into 10 raised to 23 electron, they will have what? Strong interaction with their neighboring atom. They will have a strong interaction with their neighboring atom. Due to that strong interaction, their energies will slightly differ. Means that 3s energy level, it gets splitted into 6 into 10 raised to 23 levels. Means this is level number 1, 2, 3. So, this is lastly 6 into 10 raised to 23 energy levels are there. Means every electron has a unique energy level which is different than that of what? The other energy level of other electron. So, here we are having 6 into 10 to the power 23 different energy levels are present in that 3s orbit. And what is the spacing between the two energy level? The difference between two energy level will be of the order of 1 upon 6 into 10 to the power 23, means it is 10 to the power minus 23. So, you can imagine that how closely the energy levels are lying. It means, in other words, you can say there is a continuum of energy, and this continuum of energy is called a band. Means that 3s energy level, now it is converted into what? An energy band. Energy band. Now look at this figure. Here I had shown the energy levels of electron in a different orbit. 1s, 2s, 2p, 3s. They will represent what? The allowed different energy level of what? An isolated sodium atom. These horizontal lines, they will represent the allowed energy levels of an isolated sodium atom, while these curved lines will represent the potential energy possessed by the electron, potential energy of an electron which is near to that of nucleus, due to what? Due to Coulombian interaction between electron and that of positively charged nucleus. So, in short, you remember regarding this diagram, which is a plot of energy versus interatomic distance. Horizontal lines will represent the energy levels of isolated sodium atom, while the curved lines will represent the potential energy of electron, which is near to that of nucleus due to what? Columbian interaction. Now, when two sodium atoms they brought close to each other, when two sodium atoms they brought close to each other, no doubt there will be an overlapping of atomic orbitals. But we will consider the overlapping of only the outermost atomic orbital, that is 3s orbital. Due to overlapping of atomic orbitals, what happens? Electron in the 3s orbit, they will have a strong interaction with neighboring atom. Due to their strong interaction with the nucleus of neighboring atom, potential energy of 3s electron of both the atom will change. That change in energy of electron in the 3s orbit, that change in energy of 3s electron, how is that change? The energy of 3s electron, it changes by a small amount. Means the potential energy of this electron, it may become slightly more than that of its original energy, or it may become slightly less than that of what? The original energy of electron in that 3s orbit. Means that definitely there is a slight variation in the energy of electron. So here that 3s orbit, now it has two energy level. One of the energy level, it corresponds to energy of first electron. Another energy level, it corresponds to what? Energy level of second electron. Means both these electrons in the 3s orbit, both these 3s electron will have what? They will have different energy, which are slightly less than or greater than that of original 3s orbit. So here I have shown that splitting of 3s orbit or splitting of energy level in 3s orbit into what? Two energy level. Now you can continue this when solid sodium is formed. When there is a formation of a solid sodium, n atoms, let us consider 1 mole of sodium is going to form, means in all n equal to 6 into 10 to the power 23 number of atoms. They are closely packed. Their interatomic spacing is 2 to 3 angstrom unit. Then in all 6 into 10 to the power 23 electrons, they will have a strong interaction with their neighboring atom. So there is a slight variation in the energy of 6 into 10 to the power 23 electrons which are lying in what? 3s orbit. So that 3s energy level, it gets splitted into n equal to 6 into 10 to the power 23 discrete energy level. And the spacing between two energy level is 1 upon 6 into 10 to the power 23, means 10 to the power minus 23. So let us imagine that how closely these energy levels are lying. We cannot separate one energy level from the other. Means here you can say there is a continuum of energy, and this continuum of energy is called energy band, which is shown here. Remember, due to the strong interaction between the electrons of the neighboring atom, here there is also an interaction between the electrons of what? Inner orbit also, but that interaction is what? Somewhat negligible. Means the energy level of electron in the innermost orbit will not be affected that much. They remains what? Unaffected. So you remember that during the formation of solid, there is a change in the energy level of only those electrons which are lying in the outermost orbit, because they are having a strong interaction with their neighboring atom, whereas electrons in the innermost orbit, no doubt they will have interaction with their neighboring atom, but that interaction will not change their energy, or that interaction will change their energy by negligible amount. Or in other words, you can say that the electrons in the inner orbit, their energies will remain unaffected when formation of solid is taking place. So this is how that band theory of solid, it can be explained for sodium. So now we know very well how the splitting of energy level into sub-level will take place. As we know that during the formation of 1 mole of sodium solid, N equal to 6 into 10 to the power 23 number of sodium atoms, they comes close together such that their interatomic spacing will be within the range of 2 to 3 angstrom. So only those electrons which are lying in the outermost orbit, that is 3s electron, they will have a strong interaction with their neighboring atom, and as a result of which their energy, it gets changed slightly from their original value. That is, the 3s energy level, it gets splitted into N equal to 6 into 10 to the power 23 different energy levels. Each 3s electron will have its unique energy level represented by the horizontal lines. So the 3s energy level, it gets splitted into 6 into 10 to the power 23 different energy level, and these energy levels, they are so closely packed with each other that the distance of separation between two consecutive energy level is roughly 10 to the power minus 23. Means, in other words, we can say that during the sharing of electron in the outermost orbit, there occurs a splitting of energy level into what? Continuous energy levels. 3s energy level, it gets splitted into what? Very large number of energy levels, that is 6 into 10 to the power 23, and these energy levels, they are so closely packed. In other words, you can say there is a continuum of energy. So this continuous variation in the energy level is called energy band. What is energy band? Energy band consists of large number of energy levels which are very close to each other. In other words, we can say there is a continuous variation in the energy as far as energy band is concerned. Remember here, regarding the physics point of view, because we are interested only in what? The electrical properties of semiconductor. So that's why we are just observing how strongly the electron in the outermost orbit will interact with the neighboring atom. But remember, electrons in the inner orbit also have interaction with the neighboring atom, but their interaction is what? Negligible. Electrons in the innermost orbit or electrons in the inner orbit, they will also interact with their neighboring atom during the formation of solid, but their interaction is weak. Their interaction is weak means variation in their energy is what? Very, very small. So that's why the bandwidth of 1s band or 2s band or 2p band, it is less than that of 3s band. And you remember one thing, that the bandwidth of any energy level, when energy level 1s, it gets splitted into subshells, sublevels, then the bandwidth of any energy level, it depends on how strongly the electron in that orbit will interact with their neighboring atom. Greater the interaction of electron with the neighboring atom, greater will be the bandwidth. And because electrons in the outermost orbit, they will have a strong interaction with the neighboring atom, so that's why the bandwidth of 3s orbit is what? Very, very high. 3s orbit is very, very high. Now in case of sodium, because we are just concentrating only on sodium, so in case of sodium, the topmost energy level, what is the topmost occupied energy level? In case of sodium, the topmost occupied energy level is what? 3s. So the topmost occupied energy level is a 3s level, and this topmost occupied energy level is called valence level. So what is the valence level of sodium? The valence level of sodium is the topmost occupied energy level, which is 3s level, and the topmost occupied band, the topmost occupied band or the highest occupied band is called valence band. The topmost occupied band is called a valence band. The valence band for sodium is what? 3s. That 3s band is not completely filled, it is half filled. So for sodium, the topmost occupied energy band is called valence band. The topmost occupied energy band is what? Half filled for a sodium. Topmost occupied energy band is half filled for a sodium. Now we have to define what is conduction band. What do you mean by a conduction band? See here, this valence band of sodium is half filled. 3s band is what? Half filled. If sufficient amount of energy is given to the electron in the valence band, this is a valence band, and when the electron in the valence band has given a sufficient amount of thermal energy, that electron will gain that energy and it will rises. Electron will raise to a higher energy level. Remember, on receiving the energy by the electron in the valence band, their energy level get increased. The energy level, the immediately next energy level, here is the immediately next energy level, that electron from valence band can occupy the immediately next energy level. This is a valence band and here this is immediately next energy level. So many energy levels are available, so that when the electrons in the valence band, they receive the energy, they will occupy energy level which is immediately next to what? The valence band. So the immediately next energy level that electron from valence band can occupy is called conduction level. What do you mean by conduction level? Conduction level is the energy level. The immediately next energy level that electron from valence band can occupy is called a conduction level, and here we are having so many such conduction energy level which are so closely packed with each other, so that they are again forming a band. So a band formed by conduction level is called a conduction band. A band formed by conduction level is called a conduction band. So as far as sodium is concerned, what you can say about sodium? That in case of sodium, valence band and conduction band, they will overlap with each other. Valence band and conduction band for sodium, they will what? Overlap with each other. Now remember, for a typical solid, we are having a solid, we don't know whether that solid is metal or insulator or semiconductor. We had given the information that there is a solid. So look at this figure. For any typical solid, here we can draw one conduction band, one valence band, and conduction band and valence band, they are separated by a certain gap. So the gap between the bottom of conduction band and the top of valence band, here this is what? Bottom of conduction band and this is the top of a valence band. So the energy gap between, or the gap between bottom of conduction band and the top of valence band is called energy gap, or it is also known as a forbidden energy gap. Why forbidden? Forbidden means not allowed. Means whenever electrons in the valence band, they receive the energy, then those electrons, they were not allowed to acquire any energy level. There are only certain allowed energy level that electron can occupy. So between the allowed energy level, there is a gap. Means if electrons in the valence band gain the energy, so that it can reach energy up to this level, but this level is not an allowed energy level for that electron. So remember, the gap between bottom of conduction band and the top of valence band is called energy gap. Is called an energy gap. Remember, as far as this figure is concerned, it is used to describe the energy levels of electrons in that particular solid. It has no relationship with the physical structure of that solid. This figure, this diagram has no relation, no concern with the physical structure of solid. It simply gives us the idea regarding how the energy levels of electron in that solids will be there. With that solid will be there. Now remember that as far as energy level is concerned, regarding the semiconductor, see, look at this. Suppose here this is the energy level diagram for semiconductor. All the energy levels, see here, 1s, 2s, 2p, 3s. These are 1s band, 2s band, 3s band, 2p band and 3s band. Each band consists of energy level. So in case of semiconductor, suppose here it is not a sodium, suppose we may have a semiconductor and we may draw the energy bands. So in case of semiconductor, all the energy levels in all the bands including the topmost band, in case of semiconductor, all the energy levels in all the bands including what? The topmost band, they are completely filled or they are completely occupied. All the energy levels in all the bands including what? The topmost band, they are completely filled. They are completely filled with electron at what? At 0 degree Kelvin. Remember what I am saying, that all the energy level in all the bands including topmost band in case of semiconductor, they are completely filled, so that at 0 degree Kelvin no electrons are available for conduction of electricity. No electron is allowed to enter into conduction band. Hence semiconductor, they behave like a perfect insulator at 0 degree Kelvin. But as soon as that semiconductor is kept at some finite temperature T degree Kelvin, whenever semiconductor is kept at finite temperature T degree Kelvin, we know that the electrons in that semiconductor, they will absorb Tk amount of thermal energy. What is the thermal energy received by electron? Thermal energy received by electrons in the semiconductor will be Tk, where K is known as Boltzmann constant. K is known as Boltzmann's constant. So you may think that electron in 1s band or 2s band or 2p band or in 3s band, all of them, they were receiving Tk amount of thermal energy. But only those, remember, electron in the lower bands which are completely filled, even after receiving Tk amount of energy, those electrons, they cannot move to a higher energy orbit, because higher energy orbit, they are already occupied. If I say that electron in this orbit receives Tk amount of energy, then we are hoping that this electron can move to a higher energy orbit, but higher energy orbit is already occupied. So even though these electrons, they are receiving Tk amount of energy, they will not move to a higher energy orbit, means they will not participate in conduction of electricity. But the electrons in the valence band, on receiving Tk amount of thermal energy, they will raise their energy level. They will raise their energy level and enter into higher energy level, which is a conduction level. Means electrons from valence band enters into what? Conduction band. So remember, semiconductors at 0 degree Kelvin, as far as semiconductors are concerned, at 0 degree Kelvin, all the energy levels in all the bands, including topmost band, they are completely filled. They are what? Completely filled, and at finite temperature every electron will absorb Tk amount of thermal energy, but only those electrons which are lying in the valence band on receiving Tk amount of thermal energy can raise their energy level and can enter into conduction band, and they are made available for conduction of electricity. They are made available for what? Conduction of electricity. Remember that as far as semiconductors are concerned, as far as semiconductors or as far as sodium is concerned, in case of sodium, what you can say? In case of sodium, that valence band here it is what? 3s band, and if the electron in the 3s band, even though they receive a very small amount of thermal energy, these electrons they can raise their energy level and they can enter into what? The conduction level, conduction band. So on receiving a small amount of thermal energy, electrons from the half-filled valence band can gain the energy and raise their energy to a higher level, and they are made available for conduction of electricity. Because 3s band here it is half-filled band. 3s band here it is what? A half-filled band. Remember here, as far as electrons are concerned, electrons can gain the energy on applying external electric field, electrons in the valence band. In order to make them available for conduction of electricity, what is necessary? That electrons in the valence band, they must be supplied what? Electrons in the valence band, they must be given some energy. So by applying the external electric field, electrons in the valence band can be given a small amount of energy. So remember, whenever we are using or whenever we are applying an external electric field, only those electrons which are lying in the higher energy level of valence band, only those electrons which are lying in what? The higher energy level of valence band, they can gain the small amount of energy and they becomes available for conduction of electricity, because they can enter into what? A conduction band. They can enter into a conduction band. Now the last point that is to be discussed, and that is related with what? The difference in the electrical conductivities of solid that can be explained on the basis of what? The band structure. Means whether the given solid is a metal, that is good conductors of electricity, or a semiconductor or an insulator, that can be just explained by considering only the band structure of a solid. Now in case of conductors, all the metals are good conductors of electricity. So the band structure of any conductor will be of this type. Means as far as all the metals or all the conductors of electricity are concerned, their conduction band and valence band, they will overlap with each other. Means there is no energy band gap. Energy bands, they will overlap. Means the valence band and conduction band, they will overlap. So in case of conductor, even when the electrons in valence band on receiving or whenever they gain a small amount of electrical energy, when external electric field is applied, electrons in the valence band, they gain small amount of energy and acquire the higher energy level in a conduction band, and they are made available for conduction of electricity. So just by applying an external electric field to a conductor, electrons in the valence band receives or gain small amount of energy and can reach a higher energy level in a conduction band, and these electrons, they are made available for conduction of electricity. In case of semiconductor, there is energy gap which is less than that of 1 electron volt between the valence band and conduction band. No doubt there is a small energy gap is there between valence band and that of conduction band, but as far as this energy gap is concerned, it is of the order of less than that of 1 electron volt. Less than that of what? 1 electron volt. So, electrons in the valence band, on receiving the energy just by applying a strong external electric field or just by applying an electric field, when the electrons in the valence band, they receive or they gain an energy which is less than that of 1 electron volt, that electron can gain the energy level in conduction band and they are made available for conduction of electricity. In case of insulator, there is a huge energy gap between valence band and conduction band. Remember, in case of insulator, this energy gap between valence band and conduction band, it is more than that of 5 electron volt, means it is highly impossible for the electron in valence band to acquire or to gain such a large amount of energy so that they can made available for conduction of what? Conduction of electricity. So most of the insulator, they won't allow any electric current to pass through them because it is difficult for electrons in the valence band to gain such a large amount of energy, and for that purpose one must have to apply very large amount of electric energy. So remember, on the basis of band structure of solid, what you can say now, that in case of conductor, valence band and conduction band, they overlap. So just by applying an external electric field, electron in the valence band, they gain small amount of energy and will acquire energy level in a conduction band and they are made available for conduction of electricity. In case of semiconductor, valence band and conduction band, there is a small gap in between them. But what is the range of that gap? That energy gap between valence band and conduction band, it is less than that of 1 electron volt, means when electron in the valence band, they will acquire or they will gain an energy which is less than that of 1 electron volt, can gain the energy level in conduction band and made available for conduction of electricity. In case of insulator, the energy gap between valence band and conduction band is very high. For the case of diamond, this energy gap, diamond is what? Is an example of insulator. And in case of diamond, this energy gap between valence band and conduction band is very large. It is of the order of 5 electron volt. So that's why there will not be any possibility of conduction of electricity as far as insulators are concerned, because electrons can never overcome such a large amount of energy gap, that is 5 electron volt. Now from the next lecture we will start the topic that is intrinsic and that of extrinsic semiconductor. Intrinsic and extrinsic semiconductor.